In the circuit above, 3 resistors, 2 ohms, 4 ohms, and 12 ohms are connected in parallel, and a 12-volt battery is connected across the combination. The current flowing through the 12 ohm resistor is, so this is the circuit diagram we've been given. Look at the 3 resistors that are connected in parallel. They are sharing the same terminal, which is this terminal and this. So they are that's parallel connection. And then we have a 12-volt cell connected across the combination. So we have to calculate the current that is flowing through the 12 ohm resistor. So we'll name that current I1. Then the one flowing through, that's I2, and then I3. So this is a very simple thing to do. Well, you have to know the rules. Whenever there is a parallel connection like this, the voltage across the terminals is the same. The voltage across each device or each component in a parallel connection is the same. So the voltage across these 2 ohms resistor is the same as the voltage across this, and the voltage across each of them is 12 volts. So I will say V1, that's the voltage. V1, the voltage across the 12 ohm resistor is 12 volts. Now we have to calculate the current I1, that's the current that flows through the resistor, and then the resistor itself, R1, equals to what? 12 ohms. According to Ohm's law, V equals to what? I times R, current times resistance. So the voltage, which is V1, which is the same thing as V, since it's a parallel connection, the equivalent voltage is the same as the individual voltage. So it will now be I1 times R1. If you make I1 the subject of the formula, that's dividing both sides by R1, that will be V divided by R1. So our V is 12. Our R1 is 12. 12 divided by 12, 1 ampere. So the current that will flow through the 12 ohm resistor will be 1 ampere, option B. So you can also use the same pattern to find out the current that flows through the second resistor, the third. Then you can also find out the equivalent current, that's the total current being drawn from the battery. That will be this current plus this current plus this current. Or if you can first calculate equivalent resistance, then you do V equals to what? I equivalent times R equivalent. You make I equivalent. You see the answer you will get will be the same answer as adding the individual current. So it's a very simple analysis to note. So based on this question, our answer is 1 ampere. Thank you.